Welcome students. We want to discuss the concept of planes. So before we go further, we should read this quote by Alexander Grothendieck. He was a French mathematician. He was actually stateless for first part of his life, and then he became French. He is one of the biggest algebraic geometers of all times. So his quote is the following: "One should never try to prove anything that is not almost obvious." It's quite a deep quote. Anyway, so coming back to our discussion of planes, so how is a plane uniquely determined? So plane is uniquely determined by 3 points lying on it. So you need 3 points which are non-collinear, means they do not pass through the same line. So if you take these 3 points and then these 3 points will uniquely determine the plane. Yeah. So you see, yeah, so these points will uniquely determine the plane which passes through them. Okay. Now, if you took three collinear points, then there's a unique line passing through them. But the problem is there could be many planes passing. So therefore, you can have one plane which goes like this. You can have another plane which passes through the same thing, but you have these two planes passing through this, and in fact, there are infinitely many planes passing through a given line. So you need 3 non-collinear points lying on it. Another way a plane can be determined is the following. So if you take a point, there is again infinitely many planes passing through it. But what if you fix the normal vector to the plane, it kind of basically makes the plane stabilize and you get a unique plane out of it. So this will stabilize the plane. So if you're given a point and you're given a normal or perpendicular to the plane, that's what we mean by normal, it kind of stabilizes the plane. So therefore, we need either of these two information to find out the equation of the plane. So let's start with the first equation of plane. We are going to discuss about the vector equation of the plane. So what is the idea? Suppose we have this plane with a point given on it, say this point is given to you as P x naught, y naught, z naught. Yeah, so this point P is given to you as x naught, y naught, z naught. And we are given the normal to the plane. That means we are given a line or a vector which is perpendicular to this plane. So let's call this normal as n. So let this normal be n, vector n. So what we want is, if we take any point P, so let this be any point P, X, Y, Z, we need to find a constraint on this P, X, Y, Z, right? So let the position vector of this point be R. So let this be vector R. And we want to give a condition on what R should be. So now let's look at R. So this point P, suppose it has a position vector R naught. So position vector of this point is R naught. So R naught, vector R naught. So vector R naught. Okay. And this is your R, and you want to basically give restriction on R, right? As you keep changing R, you should get all the points or the position vector of all the points on the plane. So if we use triangle inequality, we will see, sorry, if we use triangle of vector addition, we'll see that this vector is going to be, this vector here is vector R minus vector R naught. And that is, and your normal is perpendicular to the plane, so it will be perpendicular to R minus R naught, or it will be orthogonal to R minus R naught. So this would mean that this should satisfy, so should satisfy R minus R naught dot with vector n should be 0. And this is the equation of, this is the vector equation of the plane. Okay, so again, let's revisit. P R naught is position vector. So this is a point given to you, and the position vector of that is R naught. And what we do is we want to find out, given any point P, X, Y, Z, we need to find out position vector of that point. That is what the vector equation is. And what we do is we construct R minus R naught using triangle of vector addition, and we have a normal to the plane. So these dot product of these should be 0. And this is how we get the vector equation of the plane. Now we can have a scalar equation as well. So if you have, suppose n was given by A, B, C, this is your normal vector. And then your R naught is given by, because it's a position vector for X naught, Y naught, Z naught, R naught is going to be X naught, Y naught, Z naught. And R, vector R is going to be X, Y, Z. So let's substitute that in here in the scalar, in the vector equation. So we have R minus R naught dot with n equals to 0. Now this gives us R minus R naught is going to be X, Y, Z minus X naught, Y naught, Z naught dot with vector n, which is A, B, C, must give us 0. So this implies if we subtract and then take the dot product, we have X minus X naught times A plus Y minus Y naught times B plus Z minus Z naught times C equals to 0. So this already gives us the scalar equation of, so this is a scalar equation of plane passing through X naught, Y naught, Z naught, and perpendicular to n, which is given by ABC. So this is a scalar equation of the plane. Okay. However, this can be rewritten in a slightly more different format. If we expand this expression and simplify, we can write it as AX plus BY plus CZ minus X naught A plus Y naught B plus Z naught C equals to 0. And we can call this, if we choose to call this whole thing, this whole expression as equals to D, this implies AX plus by plus cz equals to d. Oh, sorry, plus d equals to 0, depending on which side you want to put it. So plus d equals to 0. So this is another equation of plane. This is easy because it helps you to do a lot of computation here, particularly the intercepts. Okay. So now let's proceed further and say, how do we find? So this was when you are given a point and the normal to the plane. Now, how would we find the equation of plane in the space that is given by 3 points? So suppose you have 3 points in the plane. So you have P, Q, and R. How do we find out the equation of the plane passing through given three given points? Okay, and these points be non-collinear. We want non-collinear if we want unique plane passing through them, right? As we already discussed, if they are collinear, then they lie on the same line. That means there are infinitely many planes passing through. So the idea is then so what do we need? We need point. And that can be done by any of P, Q, R will do, right? Now we need normal. So what is the normal in this case? So recall here, the cross product will come handy. So let's take PQ, PR. So we'll take normal is PQ cross PR. So that will do the job. So this is how we can find out the equation. So we have n and we have point, basically 1 point, and we have normal. So we can proceed with whatever we have done earlier to find out equation of such a line, such a plane. All right, so now let's see, write down the indicated plane. So we want to find out a plane that passes through P5, 7, -6 and parallel to XZ plane. So let's see. So we have X, Y, Z. Now, if you look at the XZ plane, the normal to XZ plane is basically any vector along. So a normal to XZ plane is any vector along y-axis. So this is the XZ plane, and then the normal here is any vector along y-axis, and we know particularly one vector along y-axis, which is our vector j. So in this case, point is 5, 7, 6. So we have R naught is a position vector of 0.576, which is going to be 576. So 5, 7 minus 6. And we have n. Our normal is given by vector j, which is 0, 1, 0. So therefore, vector equation is x, y, z minus, so we need r minus r naught dot with n equals to 0. So this is going to be 5, 7 minus 6 dot with 0, 1, 0 equals to 0. So this is your vector equation. And then if you want scalar equation, then what we'll do is we'll multiply it out. So we have x minus 5 times 0 plus y minus 7 times 1 plus z plus 6 times 0 equals to 0. And if you simplify, we get y minus 7 equals to 0. So this is the equation of the plane. So geometrically thinking about this, this is nothing but a plane. So suppose that this point is 7, you are basically looking at a parallel plane passing through this point and is parallel to the plane. Is parallel to the plane here, xy plane. Okay, so we are looking at this plane. Right. Now let's move on to the next problem. So another write down equation of plane 5, 7, 4. So we have 5, P point is 5, 1, 4 that lies on the plane and is parallel to 2x plus 3y plus 4z. So now let's look at two parallel planes, one stacked on top of each other. We have two parallel planes, say P1 and P2. They are parallel if we take the normal of this guy and the normal of this guy, they are parallel as well. Okay, so two planes are parallel, so two planes are parallel if their normals are parallel, right? If their normal vectors are parallel. So in that case, what we have is, so the normal we need is again going to be 2, 3, 4, right? So why is that? We can read from the vector, we can read the normal from the equation. So this gives us A, B, C is the normal. So we can read the normal from the coefficients. So if we have AX plus BY, so in this case, we get normal is 2, 3, 4. So N is normal to 2x plus 3y plus 4z equals to 0 is normal, is the normal vector. So it is a normal vector to 2x plus 3y plus 4z equals to 0. So in particular, it is also, this normal will also do the job for our plane as well. Yeah, so therefore, required equation of plane of the plane is, essentially you take the same point is 5, 7, 1, 4, so x minus 5 times 2 plus, I'm going to use this equation here now, x minus x naught a plus y minus y naught b plus z minus z naught times c equals to 0. So I have 2 times x minus x naught, 3 times x minus y minus 1 plus 4 times z minus 1 equals to 0. So I'm writing the scalar equation directly. You can also write down the vector equation if you wish to. And if you want to simplify, you can simplify as well to get 2x plus 3y plus 4z. equals to or plus, so minus 10 minus 3 minus 13 minus 13 minus 4 minus 13 minus 4 is going to be minus 17, so 0. So this is the equation of our required plane. So you see that two planes are parallel if their coefficients of x, y, and z are same, or they are multiple of each other. Okay. So we can write that down as another observation. So we have ax plus by plus cz plus d equals to 0 is parallel to ax1 plus by1 plus cz1 equals to d1. So a1x actually. So these two planes are parallel if you have a, b, c. Vector is sum alpha times a1, b1, c1. Yeah, essentially saying that they are parallel for some. So now we want to find out equation of the plane which passes through 246.246 and contains the line x equals to 7 minus 3t, y equals to 3 plus 4t, and z equals to 5 plus 2t. So let me draw the scenario. So this is the scenario we are in. We have a line here. So our line, let this be line L, which is given here. And we are given a point here, P, which is, so this point is P246. And we want to find out equation of this plane which contains this line and that point. So what do we need really? Again, recall, we need a point and a normal to the plane. So the way we can get a normal or perpendicular to this plane is to find out two vectors which are not parallel and take their cross product. So one vector is already given to us. So vector v. So vector v is minus 3, 4, 2. This is the direction of line. Is direction of line. So we are already given the direction of the line, and now we need another vector which is not parallel to this vector and still lies in the plane. So the idea would be to find a point here, say point Q, and then join this guys. So get QP, so QP, and then take cross with V, and that will be our normal vector N. And it will be given by QP. So QP cross with V. So vector V has the direction same as line. And if you take the cross product, the normal will be in the downward direction using the right hand rule. Okay. So now the goal is to compute. So the goal is to find some vector Q. So Q, so set t equals to 0. Set t equals to 0. We get Q, we are calling it Q, which is 7, 3, 5, and this lies on line, right? A point on the line. the point on the line. So now we want to compute QP, and QP is, so first of all, QP is QP, vector QP is OP minus OQ. OP is 2, 4, 6. OQ is here 7, 3, 5. And we subtract them to get minus 5, 1, 1. So this is our QP. So therefore, normal is cross product of these two guys, which is I, J, K. Then we have QP, which is minus 5, 1, 1. And then we have V, which is minus 3, 4, 2. And then we get, this is going to be 1, so 2 minus 4. So 2 minus 4 is minus 2i minus j times, so minus 10 plus 3, so minus 10 plus 3, which will give us minus 10 plus 3, which will give us minus of 7, minus 7, so this will become 7j, and then the k times minus 5, so minus 20 plus 3, so it becomes minus 17, so minus 17k. This is going to be, if I write it in, minus 2, 7, minus 17. So therefore, the vector equation of our plane, of the required plane, the plane in the question is x, y, z minus p. So what is the position of point P? Is going to be 2, 4, 6 dot product with the normal, which is minus 2, 7, minus 17 equals to 0. Now the scalar equation can be written as, scalar equation is nothing but once you take the dot product of your vector equation, you get your scalar equation. So what is our scalar equation? Scalar equation is x minus 2 times minus 2 plus y minus 4 times 7 plus z minus 6 times minus 17 equals to 0. So this is the scalar equation. Yeah. Right. So you can simplify it if you wish to. Right. Now we want to discuss about angle between the planes. So in general, if you're given a plane P1, this is plane P1, and plane P2, then if the angle between them is theta, you can see that angle between their normals is also theta. So therefore we get the angle between the planes two planes is equal to angle between their normal vectors. So in that case, here what is the normal vector here? We can read the normal vector. So if this is your plane P1, and if this is a plane P2, normal can be read just by reading the coefficient. So N1 is going to be 3 minus 2, 1. N2 is going to be 2, 3 minus 2. And hence the angle between them is given by cos theta equals to N1 dot N2 divided by length of N1 times length of N2. Now N1 dot N2 is going to be 3 times this, so it's going to be 6 minus 6 plus 2, and then that divided by length of N1, which is going to be 3 square plus 2 square plus 1 square, and length of N2 is going to be 2 square plus 3 square plus 2 square. So the top simplifies to minus 2, sorry, plus top simplifies to 2, and the bottom simplifies to 3 square, 9, 9 plus 1, 10, so square root of 14. So 3 squared, 9, 9 plus 8, 17. So this implies theta equals to cos inverse of 2 by square root of 14 multiplied by square root of 17. So this is the equation, sorry, this is the angle between these two planes. Now let's look at the next question. So symmetric equation of line of intersection. So first of all, whenever two planes intersect, they will intersect in a line. Yeah, so we have one plane which is given by the following, and the second plane is so we have these two planes. So let's work this idea in generality first. So the first plane is, say, let this be P1. So we have these two planes, say, call P1. So the first plane be P1. And the other plane be P2. P2. Now we want to find out what is the line of intersection of these two planes. So we want to find out symmetric equation of these two. So this is your P1 and this is P2, and we want to compute the intersection of these two planes. So as you can see, the intersection of these two planes is this line here. So we need to find out intersection. So one way to do this is find out the direction of this line and a point on this line. So to do that, what we'll do is the following. The direction of the line is going to be the cross product of N1 and N2, right? Because N1 is normal to this plane, N2 is also normal to P2, and then if you take the cross product of this, you will get the direction of the line V. So we have V equals to N1 cross N2. That is again I, J, K. So N1 is 3 minus 2, 1, N2 is 2, 3 minus 2. We need to take cross product of these two guys. So let's compute the cross product. It turns out that the cross product is 1, 8, 13. Now we need to find out, so we found out the cross product. Now to find a point, find point on intersection of intersection, point on the line. So we need to find the point on the line, so we'll equate them and solve for it together. So let's do that. So what we'll do is so it's a line, so we can take one of the variables 0. So let y equals to 0. So this will give us, the first equation becomes 3x plus z equals to 5, and we get 2x minus 2z equals to 3. Now, when we solve this equation together, we get, this will give us simultaneous equation. When you solve it together, you get x equals to 13 over 8 and z equals to 1 over 8. So therefore, the equation of line is, so vector equation of line can be given by r of t equals to point, which is 0, 1 over 8, plus t times v, which is 1, 8, 13. And symmetric equation is given by x minus x0, so x minus 13 over 8 divided by 1 equals to y minus 0 divided by 8 equals to z minus 1 over 8 divided by 13. So this is the equation of our required lines. So now next thing we want to compute. Note that you could have done it directly by computing the intersection of these lines, these planes. You could eliminate a variable, and then you could do it directly as well, okay, without going to finding the vector and so on and so forth. Okay, we'll come back to it after this part and see how does that works. So the next problem is find the distance from point P113 to the plane 3x minus 2y plus z equals to 5. So we'll first work this problem in generality. So we have a plane. So we have a plane, and we want to basically, and we have a point which is not on the plane, say P. And suppose the coordinate of these points are x0, y0, and z0. And we want to find out this distance. This distance is going to be perpendicular distance. So we will need to find out this d. So what we'll do is we'll take any point P on the plane. So P is there. So let's take P1, which is given by, say, x1, y1, z1. And then we'll join these two. So we will get, and then join these guys as well. So let this be vector B. This angle is theta. Now D can be seen as this vector here is the normal vector. Normal vector n. So D can be seen as a projection of B onto N, the scalar projection, right? So D essentially is D is equal to scalar projection, which is given by component of B in the direction of N. Right? That gives us this length, as we have seen already earlier when we're doing the. So this part is given by D, and we will take the absolute value of this because the component could be negative as well. So value of this guy. So in this case, let's work it out. So, and suppose on top of this, the equation of the plane is given by ax plus by plus cz plus d equals to 0. Okay. We are trying to find a general formula for this. So, and here we have x1, y1, z1. So first of all, let's find vector b. So vector b is going to be p1 p, which is going to be x minus x1. So x0 minus x1, y0 minus y1, z0 minus z1. Therefore, d equals to, so now we need to write down n as well. So n, let n be given by, so normal to this plane is given by a, b, c. Right? That is the connection between equation of plane and normal to the plane. So d is given by b. So the formula for the scalar projection is b dot n divided by length of n. So this is going to be length of n, that means length of vector a, b, c, and on top we have absolute value of b dot n. So b is x0 minus x1, comma y0 minus y1, then z0 minus z1 dot with a, b, c. Now if we write it down, we get ax naught. We expand this out, we get ax naught plus by naught plus c z naught minus, in bracket, a x1 plus b y1 plus c z1, length of this divided by a square plus b square plus c square. Now note that since this x1 y1 z1 lies on the plane, so since x1 y1 z1 lies on the plane, it must satisfy the equation. We have ax1 plus by1 plus cz1 equal plus d equals to 0. This becomes minus d. And when we put that back there, we get, therefore, b equals to ax naught plus by naught plus cz naught plus d divided by length of a square plus b square plus c square. Now, so therefore, we have worked out the general formula. Now we can work out with our equation of plane. So we have x naught, y naught, z naught, p equals to 1, 1, 3. And the equation of plane is given by 3 minus 2, 5. So 3x minus 2y plus z minus 5 equals to 0. So therefore, distance d is going to be So take this plane. Instead of this, we have 1. Instead of 2, we will have 1. Instead of z, we'll have 3 minus 5. Absolute value of this divided by square root of a square, 3 square plus 2 square plus 1 square. Now that is going to be 3 plus 3, 6. So 6 minus 7 is 1, minus 1, and absolute value of that. So this is the required distance. Okay. So now I have one more issue here. So you have these two equations, and we could have worked out directly their intersection as well. Okay. Another way of finding the intersection. So let's work on that. So we have 3x minus 2y. So what we can do is we can make linear equations out of them and work it out directly. Or we can get rid of one of the variables and work it out. So for example, let's take 3x minus 2y plus z equals to 5. And then we have 2x plus 3y minus 2z equals to 3. So if we solve this together, we will get, if we eliminate this, we can eliminate it in the following way. We can multiply this equation, the first equation, by 2. So we get, I'm going to multiply the first equation by 2 and write it down. So we get 6x. So 6x minus 4y plus 2z equals to 10. And then if I add them up, I get 8x minus y equals to 13. And now this implies x equals to y plus 13 over 8. Now that is one setup. So this was equation 1. So equation of plane P1 times 2. Okay. And then this was equation of plane P2, and then we added them up. Now let's try to take or let's try to get rid of z variable now. So the way we'll get rid of z is, sorry, we already got rid of z. Now let's get rid of another variable, say y. So to get rid of y, I'll take p1 times 2, and then I'll take p2 times 3. The p1 times, so the idea is to get rid of y variable, so p1 times 3 and p2 times 2. So this will give us, p1 times 3 will give us, this implies 9x minus 6y plus 3z equals to 15. And then we get, so 4x plus 6y minus 4z equals to 6. Then when we add them together, we get 13x minus z equals to 21. And this gives us, again, x equals to z plus 21 divided by 13. And then if we equate this
take these two equations. One equation is this guy, other equation is this guy, and combine them together. This gives us x by 1 equals to y plus 13 by 8 equals to z plus 21 by 13. So in this case, we did not use anything except for the idea of eliminating the variable. Okay, so that's one way of doing it as well. Then other ways, basically, you can take a matrix and try to solve, try to reduce it into reduced row echelon form, and from there also you can work it out. So there are many ways we can solve this problem, right? So thanks for your attention.